Okay, hi everyone. My name is Salman Zafran and my metric number is 73995. Okay, so now I will introduce the description of our application for today, which is the rocket propulsion. So first we will look into the theoretical background. So what is rocket propulsion? So rocket propulsion is a method of producing thrust by expelling mass in the opposite direction of the desired motion. So in this case, the expelled mass is actually the rocket fuel that is being combusted and being released in the opposite motion of the rocket motion. So the key component that play a crucial function in propelling the rocket is the nozzle. So the nozzle is actually the components that are located at the hind side of the rocket. So the functions of the nozzle is to reduce the pressure, which from the Bernoulli's equation, reduced pressure will result to the increase of velocity. Okay, so in our presentation for today, we will be discussing on two main questions, which is how does the energy is conserved according to first law of thermodynamics, and how does the propulsion relates to the second law of thermodynamics. So we will look deeper into how does this application relates to the first law and the second law of thermodynamics. Now I will explain on the first law of thermodynamics. So, in the first law of thermodynamics, it states that any form of energy is conserved in a system. So, this relates to the conservation of energy. So, this proves that the energy could not be created nor be destroyed, and it can only change into another form of energy. So for the fundamental formula is the change in internal energy is equals to heat energy minus the work done by the object. Okay, so now I will talk on the forms of energy in our application for today, which is rocket propulsion. So the first type of energy is the chemical energy. So this energy is produced from the behavior of the molecules inside the rocket fuel. And then from the chemical energy, after it is being combusted, it will generate a thrust. And the thrust will propel the rocket upwards, and this will produce another form of energy, which is the kinetic energy. And we also have the heat energy. So as we know, combustion will produce heat. So in this application, usually heat energy is released to the surroundings.
Assalamualaikum and hi, my name is Lufi Shamsufido Bil Maharif and my metric number is 215518. So in the rocket propulsions, it also has the second law of thermodynamics related to it. So for the second law of thermodynamics, it states that it is impossible for a heat engine to convert all the heat it receives from a thermal energy reservoir to work. So for the second one is the thermal efficiency is not equals to 100%. This is means that the rocket propulsion is also considered as a jet engine or a heat engine. So in a Carnot equation, this is also considered as irreversible process, which means the heat loss, the energy lost to the surroundings in the form of heat.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akil bin Zulkifli and my metric number is 215710. So I will continue with first law of thermodynamic in rocket propulsion. So as we know, first law of thermodynamics encloses the conservation of energy. Thus, in rocket propulsion, fuel is ejected from the rocket with relative velocity, which is u. A mass of fuel is ejected and the rest of the rocket has a mass. So by conservation momentum, the velocity of the rocket will increase by m/m times u. So now suppose the rocket initially has velocity the change in kinetic energy of the fuel is equal to 1 over 2 times m times in bracket v minus u, which is final minus initial velocity square, minus 1 over 2 mv square is equal to 1 over 2 mu square minus muv. Next, the change in kinetic energy for the rocket is 1 over 2 times mass of the rocket bracket v plus m over m times u square minus 1 over 2 mu square is equal to 1 m square 1 over 2 m square divided by m times u square plus muv. Thus, the sum of these two must be total chemical energy release, which should not depend on V. And indeed, the extra MUV term in different in kinetic energy of rocket is exactly cancelled by the negative MUV term in different in kinetic energy of fuel. So, it shows that rocket propulsion follow the first law of thermodynamics. So now I will continue with second law of thermodynamics which involve in rocket propulsion. So the second law of thermodynamics indicate that while many physical processes that satisfy the first law are possible, the only processes that occur in nature are those for which the entropy of the system either remains constant or increases. So what is entropy? Entropy is a thermodynamic property that represents the degree of the disorder or randomness in a system. In the context of rocket propulsion, it provides insights into the changes in energy distribution and heat transfer within the engine. Since thermodynamics deal only with the macro scale, the change in entropy delta S is defined here to be the heat transfer delta Q into the system divided by temperature, which is T. So, the example of entropy in rocket propulsion is combustion process, expansion of gases, and lastly, efficiency consideration of the rocket propulsion. So, I think that's all from us. Thank you.